Welcome to the presentation on systems of linear equations. So let's get started and see what this is all about. So let's say I had two equations now. The first equation, let me write it as 9x minus 4y equals minus 78. And the second equation I will write as 4x plus y is equal to minus 18. Now what we're going to do now is we're actually going to use both equations to solve for x and y. We already know that if you have one equation and it has one variable, it's very easy to solve for that one variable. But now we have two equations. You can almost view them as two constraints, and we're going to solve for both variables. And you might be a little confused. Boy, how does that work? Is it just magic that two equations can solve for two variables? Well, it's not, because you can actually rearrange each of these equations so that they look kind of in the normal y equals mx plus b format. And I'm not going to draw these actual two equations because I don't know what they look like. But if this was a coordinate axis, and I don't know what that first line actually does look like, we could do another module where we figure it out. But let's just say, for sake of argument, that first line, all the x's and y's that satisfy 9x minus 4y equals negative 78, let's say it looks something like that. And let's say all of the x's and y's that satisfy that second equation, 4x plus y equals negative 18, let's say that looks something like this. Right? So on a line is all of the x's and y's that satisfy this equation. And on the green line are all the x's and y's that satisfy this equation. But there's only one pair of x and y that satisfy both equations. And you could guess where that is. That's right here, right? Whatever that point is, I'll do it in pink for emphasis. Whatever this point is, notice it's on both lines. So whatever x and y that is would be the solution to this system of equations. So let's actually figure out how to do that. So what we want to do is eliminate a variable, because if we can eliminate a variable, then we can just solve for the one that's left over. And the way to do that, let's say I feel like eliminating this y. I think you'll get an intuition for how we can do that later on. And the way I'm going to do that is I'm going to make it so that when I add this to this, they cancel out. Well, they don't cancel out right now, so I have to multiply this bottom equation by 4. And I think it'll be obvious why I'm doing it. So let's multiply this bottom equation by 4. And I get 16x plus 4y is equal to, let's see, 40 plus 32 minus 72. Right? All I did is I multiplied both sides of this equation by 4. Right? And you have to multiply every term because it's distributive property and both sides. Whatever you do one side, you have to do the other. Let me rewrite that top equation again, and I'll write it in the same color just so you can keep track of things. 9x minus 4y is equal to minus 78. Okay. Well, now, if we were to add these two equations, when you add equations, you just add the left side and you add the right side. Well, when you add, you have 16x plus 9x. Well, that equals 25x. Right? 16 plus 9. 4y minus 4, that just equals 0, so that's plus 0, equals, and then we have minus 72 minus 78. So let's see, that's minus 140, 150, minus 150, right? Just adding them all together. So we have 25x equals 150. Well, we could just divide both sides by 25, or multiply both sides by 1 over 25. It's the same thing. You get x equals, negative 150. X equals minus 6. There we solve the x coordinate. Now to solve the y coordinate, we can just use either one of these equations up at top. So let's use this one because it seems a little bit marginally simpler. So we just substitute the x back in there, and we get 4 times minus 6 plus y is equal to minus 18. Go up here. 4 times minus 6, we get minus 24 plus y is equal to minus 18. We get y is equal to 24 minus 18. So y is equal to 6. So these two lines, or these two equations you could even say, intersect at the point x is minus 6 and and y is plus 6. So they actually intersect someplace around here instead. I drew these, the lines probably look something more like that. But that's pretty cool, no? We actually solved for two variables using two equations. Let's see how much time.
Alright, so the video you just watched was on multiplying so we could cancel out a common term here. So we can do something else if you didn't really like that. So we can solve a system of equations with substitution. So all that's going to be is we are going to solve one of these equations for one of the variables, then we're going to substitute it back into the other problem, and then solve the other one. So I'm going to choose this one down here because y is already by itself, and that'll be easy for me to solve for. So if I go minus 4x to this, minus 4x over here, I'm going to get y equals a negative 4x minus 18. Alright, so now I got a value for y. So now I have this equation, 9x minus 4y equals negative 78. So now wherever I see a y, I'm going to plug in the negative 4x minus 18. So this is the 9x minus 4 times negative 4x minus 18, and then equals negative 78. Alright, so write down what you didn't use, and we're going to use our order of operations. I'm going to distribute this negative 4 through the problem because I got my minus here, so I got to distribute it through. So I'm going to get 9x, and then the negative 4 times negative 4 is going to give me a positive 16x, and then I'm going to go negative 4 times a negative 18. So that's going to be plus, see, 4 times 8 is 32, carry the 3, so that's going to give me a 72 equals negative 78. Alright, so now you combine like terms. I'm going to have 25x plus 72 equals negative 78. Solve, so minus 72, minus 72. This is going to be 25x equals negative 150, divide by 25, divide by 25, and then so x is going to equal a negative 6. Alright, so now we have our value for x, so we can take that value for x and we can plug it into either equation. Since I used the second equation, I'm going to go ahead and use the first one for it. So I'm going to go 9 times negative 6 minus 4y equals negative 78. So all I did is I took this equation, and wherever I saw this x, I put in what I found x was. So 9 times negative 6 is going to be a negative 54, and I'm going to go minus 4y equals negative 78. Alright, so now I got to add the 54 to both sides because I want to get y by itself. So now I'm left with negative 4y equals, this is going to be a negative 24. Divide both sides by negative 4. So I'll get a y equals positive 6. So my solution to this would be a negative 6, comma 6. Alright, so that was the other way we could have solved. So we're going to go ahead and take a look at another problem.
So let's say I had the points. I'm going to write them in two different colors again. Minus 7x minus 4y equals 9, and then the second equation is going to be x plus 2y is equal to 3. Now if I were just doing this just as fast as possible, I would probably multiply this equation times 7 and it would automatically cancel out. But that's the easy way. I'm going to show you that sometimes you might have to multiply both equations. And we're going to, actually not in this case. So actually let's just do it the fast to multiply both equations. And we're going to, actually not in this case. So actually let's just do it the fast way, real fast. So let's multiply this bottom equation by 7. And the whole reason why I want to multiply by 7 is because I want this to cancel out with this. If you multiply 7, you get 7x plus 14y is equal to 21. Let's write that first equation down. Again, minus 7x minus 4y is equal to 9. Now we just add. This is a positive 7x. It just almost looks like a negative though. Okay, so that's 0. 14 minus 4y plus 10y is equal to 30. Y is equal to 3. And now we just substitute back either one of these equations. Let's do that one. X plus 2 times y, that's 2 times 3. X plus 6 equals 3. So we get x super easy. The intercept. I hope I didn't do it too fast. Well, you can pause it and watch it again if you have to. Okay. So, these two lines intersect at the point -3, 3.
Alright, so again, we can solve these by just figuring out what one variable equals and then substituting it back in. So I'm going to choose this one just because x is by itself already, so we can figure that out. So all I got to do is I got to go minus 2y to this one, so minus 2y to this side. So I'm going to be left with x equals a negative 2y plus 3. Alright, so now I'm going to substitute this in. So I got a negative 7x minus a 4y equals a 9. So now wherever I see an x, I'm going to put my negative 2y plus 3. So I'm going negative 7 times negative 2y plus 3, and then minus 4y equals 9. So distribute this negative 7 through. That's going to be a 14y. Negative 7 times a positive 3 is going to give me a minus 21 minus 4y equals 9. We're going to combine like terms. 10y minus 21 equals 9. Add 21 to both sides. So now I got 10y equals 30. Divide by 10. So y equals 3. Alright, now, so I figured out y. So now all I got to do is figure out my x. So I'll use my x plus 2y equals 3. So substitute in for my y. So I'm going to get x plus 6 equals 3. Subtract 6 from both sides. X equals negative 3. So my coordinates for the solution to the system of equations would be negative 3, 3. So you can use any method you want. You can use the method from the Khan Academy videos we just saw, where he figured out a way to multiply one of these equations in order to get rid of one of the variables and then just solve and substitute in. Or you can do it the way I showed you, where you solve for one variable, substitute that back into the other equation, solve for the single variable you have, and then substitute that number in for the other one to find the missing variable. So if you have any questions, come on in and ask.